Today we will discuss about the determination of the velocity ratio in case of a epicyclic gear train. So in the previous material what I have shared, I have discussed about the types of a gear train. So today we are going to discuss about the determination of velocity ratio in case of a epicyclic gear train. Okay, velocity ratio in case of a epicyclic gear train. So what is a epicyclic gear train? So consider this as gear A and gear B. So this is gear A and gear B. These are the axis of gear A and axis of gear B. So it is connected by another fixed element. Okay, so what is that? It is a fixed R. Okay, so here we have three elements, that is a gear A, gear B, and arm is there which is fixed. So how we want to determine the velocity ratio? Let us consider that ZA is the number of teeth for gear A and ZB is number of teeth for gear B. Now let us assume that this arm is fixed. Arm is fixed. Now what is an epicyclic gear train? What do you mean by that? So epicyclic is what? It is the revolution of one element over the another element. Epicyclic means it is a cyclic motion of one element over the another element. So here we have to make some assumptions, that is let gear A rotate anti-clockwise direction. Let us assume that the gear A is rotating in the anti-clockwise direction. So that thing will take it as positive, that is the counterclockwise direction motion is positive. Because of this rotation of gear A, what happens to gear B? Gear B will rotate in the positive clockwise direction, which can be taken as negative. So negative in case of clockwise rotation. So this is the convention that we are going to follow, that is gear A will be rotating anti-clockwise direction, that is taken as positive, and gear B will be rotating in the clockwise direction, that will be the negative sense. So now how to determine the velocity ratio? So how to determine the unknown velocity ratio of any of this element, any of the element of those three elements. So for that determination we have two methods to determine. That is one method is a tabular method and the another method is a algebraic method. So we are concerned about tabular method. Now let us find how to determine it using a tabular method. So here tabular method. In the tabular method we need to have a table. So in the table the first column is for conditions and the second column is for R, C, and the third column is for gear A, and lastly we have a fourth column that is for gear B. So this is how the tabular method looks. Now in the first row, so what is the condition? First condition is what? We have arm is fixed, and gear A is given +1 revolution in counterclockwise direction. Arm is fixed, gear A is given +1 revolution in the counterclockwise direction. So because of that, what is the motions that will be imparted in these elements? So arm C is fixed, so it will not be having any sort of motion. Gear A will have +1 motion. Plus is because it is anti-clockwise direction is taken as plus. So +1 revolution is there. And what is the motion that will be given to gear B now? So since it will be rotating in the clockwise direction, we have a minus sign, and the ratio is what is ZA by ZB, that is a number of teeth of gear A to the number of teeth of gear B. Okay, so this is the conditions given. Next, in the second row, what we are going to do is we are going to give another revolution. So that is we give a X revolution. Okay, a X revolution is given to the elements. X revolution is given. So what is the thing we have to do is multiply X to the above row elements. The elements in the above row, you multiply X. If you multiply X into 0, you will get 0, and here you will get plus X, and here minus X, ZA by ZB. So this is about the second row. Now go for the third row. The third row, what is the conditions we are setting? We want to give one more revolution, that is Y. Okay. So we have to give one more revolution, Y revolution. So what we are going to do? Add. We have to add Y revolution to the above elements. So if you add Y revolution to the above elements, what happens? This will become Y. Now we are adding, we are not multiplying, so get Y. And here you will have Y plus X. And here you will get Y minus X ZA by ZB. Okay. Now, by doing so, what we are going to find out? So here you can observe that the last element, that is a fourth column and third row, last element. So if you go for this element, so what does it denote? By knowing the motions of any two elements, okay, by knowing the motion characteristics of any two elements, we can calculate the third unknown element motion, whatever the velocity ratio is there, we can calculate. Okay, so this is the tabular method, and this method, okay, this whatever the sequence of operations is there. This operations, this methodology, we are going to use it for solving many number of problems that we are going to solve in the coming classes.